All right, homework 6, problem 1, part D. So part D asks us to find three things. Wants to find expected value of x, expected value of y, and expected value of xy. So, expected value of x is just going to be x times f of xy over the integral. So we have expected value of x is just going to be, by the way, these should be random variables. We have the double integral. F of xy is just 8xy times, so we have x times 8xy. And then we're going to integrate. I'm integrating first with respect to y, and then with respect to x. If you recall from part, let me find the part now. We have part B, part C, part A. We have the figure here. So y is going to go from x to 1. And then x is going to go from 0 to 1. So now we just evaluate the integral. So first we do the integral with respect to y. We have integral from 0 to 1 of 8 x squared. The integral of y is going to be y squared over 2 evaluated from x to 1. So that's just going to become 1/2 minus x squared over 2 dx. And now we have the integral 0 to 1. So let's try this. Let's do this, sorry. We take out the 2's, make this a 4. So we're going to have integral of 4. I have an x squared. Whoops. X squared times 4. There's an x squared here. Minus the integral from 0 to 1 of 4 x to the 4th dx. We can pull the 4 out because it's a constant, so we have a 4 out. X squared dx minus x to the 4th dx. 0 to 1, 0 to 1. Okay, this guy becomes x cubed over 3, evaluated between 0 and 1. So first, let me put the constant. So that's just going to become 1/3. This is going to become x to the 5th over 5, evaluated from 0 to 1, which just becomes 1/5. My brackets don't match, but it's okay. So now we're going to have 4 times, put them onto the same denominator. This is just going to become 8 over 15. So that's our expected value of x. Now, we want to find expected value of y. So it's going to be the same thing, except we're going to replace the x that we had here with a y. So we have the integrals, same integral, x to 1, this for y, and this one is for x. So we have y, 8xy, integrate first with respect to y from x to 1, and then with respect to x from 0 to 1. So, what's going to happen? Integral from 0 to 1 of 8x. These two y's combine together to become y squared. The integral of y squared is going to be y cubed over 3, evaluated from x to 1. So that's just going to become 1/3 minus x cubed over 3 dx. Now, we can take the 8/3 out as a common factor. So that's just going to become what? We're going to have 8. I said 8 over 3 as a common factor. The x comes in here. So we have x dx from 0 to 1 minus x cubed. Sorry, not x cubed, x to the 4th. My mistake, because the x comes in between 0 and 1. So, now, we have the 8/3. This is going to become, so 8/3. This is going to become x squared over 2 evaluated from 0 to 1. So that's just going to become 1/2. This is going to become x to the 5 over 5, evaluated from 0 to 1. That's just going to become 1/5. Put them on the same denominator. So we have here a 10. This becomes 5 minus 2. 5 minus 2 is 3. 3 cancels with this. So we're left with 8 over 10. Reducing to lowest terms, we get 4 over 5. So that's the expected value of y. Okay, now we have one more, so we got this out of the way, we got this out of the way, now we just want that guy. Okay. Expected value of xy. So, that's basically going to be the same thing, except we're going to multiply by xy instead of just x or y. So here we have the same integral. I integrate with respect to y first from x to 1, and then for x. So dy dx. Then we're going to have xy times 8xy. So we can pull the 8 out as a common factor, as a constant. So this is going to become x squared y squared dy dx. Y goes from 0 to 1. X goes from, y goes from x to 1. Y goes from x to 1, and x goes from 0 to 1. So the integral with respect to y is going to be y cubed over 3, evaluated from x to 1. So we have 8 x squared. We're going to have 1 over 3 minus x cubed over 3 dx. This is going to equal, we can take the 1/3 common factor out, so we have 8 over 3. This is the first integral. We're going to have x squared dx from 0 to 1. Then we have minus integral x squared times x to the 3rd is x to the 5th. So we're going to have x to the 5th dx. So we have here, we have the 8/3 common factor. X squared becomes x cubed over 3. Between 0 and 1 becomes 1/3. This becomes x to the 6th over 6 between 0 and 1, which becomes 1 over 6. So, find the common denominator. So we have 6 minus 3 over 18. This becomes 3 over 18. These cancel, so we're left with 8 over 18. So that becomes 4 over 9. Right, which is expected value of xy. Okay, now we do part E. So what does part E asks us? Part E says, prove or disprove that x and y are uncorrelated. Okay, so E says wants to find whether or not x and y are uncorrelated or not. So the condition for uncorrelated, I might have spelled that wrong. Did I spell it? I did not spell it wrong. I spelled it correctly. Uncorrelated, the condition is expected value of xy must be equal to the expected value of x times the expected value of y. So that's for uncorrelated. So now we'll use the numbers that we just calculated to see whether or not this is uncorrelated. So E of xy is just 4 over 9. And we're going to check if that's going to be equal to expected value of x, 8 over 15, times expected value of y, 4 over 5. And we can see that it's not the case. So that means that x and y are in fact correlated. Now part F. Move to another page. Part F. Part F wants us to find and sketch the conditional density functions. So they want us to find f of y given x and f of x given y. Okay, simple enough. So this, I'm just going to put a little bar here. F of y given x, by definition, is f of xy over f of x. This, by definition, f of xy over f of y. So, we found the marginal density functions earlier in part, I think it was B, part B. So we can refer back to part B. So let's refer back to part B. So let me get myself organized here. Part B. So here are our marginal density functions, f of x and f of y. We know what f of xy was. F of xy is simply 8xy. F of x is this guy over here, which is 4x minus 4x cubed. This guy is this over 4y cubed. So that is f, but let's first, let's clean this up a little bit. These 4's cancel with this 8 to make a 2. So here we have, also an x cancels here. So this x cancels with this, with this. So what are we left with? We're left with 2y over 1 minus x squared. So this is the first conditional density function. These cancel to make a 2. This cancels with this. So we're left with 2x over y squared. This is the second conditional density function. Let me continue this little pipe down here. So now they want us to sketch it. So let's sketch it. So I'm going to sketch this guy, which is, let me make this a little nicer here. I want us to sketch f of y given x for fixed x. Because if it weren't for fixed x, we'd have a density plot, three-dimensional plot. So this guy, draw this on the graph here. And this is going to be f of x, y for fixed y. So this is going to be y, and this is going to be x. So, for fixed x, 2 over 1 minus x is a constant times y. So it's just going to be a line. Some slope. And the slope is going to be 2 over 1 minus x squared. For this guy, we're fixing y. So 2 over y squared is a constant times x again becomes a line. By the way, both of these lines are exactly crossing the origin. So this is going to be a line of slope 2x over y. I'm sorry. This is going to be a slope of 2 over y squared. So that completes part F. And now we have part G, the last part. Okay, so part G wants us to find expected value, a conditional expected value of y given x. They also want us to find expected value of y given x random variable. Then they want us to find this and this. So let's start with this first guy over here. Expected value of y given x is going to be equal to y times f of y given x dy. Now, referring back to the figure that we made in part A, the y is going to go from x to 1. So that's this integral. What was f of y given x? Boom, we have it right here. So we have my integral y, then we have 2y over 1 minus x squared dy from x to 1. The 1 minus x squared, take it out because I'm not integrating with respect to x, so we don't care. 1 over 1 minus x squared. Also the 2 is a constant. So we're left with the integral from x to 1 of y squared dy. So what's that going to become? Y cubed over 3. So we have our constant here. And we're going to have 1 over 3 minus x cubed over 3. And what is that going to become? So we can take out the 3. So we have 2 over 3. And inside here we'll just put, because they're both under the same denominator, we can put this. So that is the first, this guy right here, e of y given x. E of y given x random variable is just going to be the same thing, except I'm replacing x with a random variable. So this is just going to be 2/3 1 minus x random variable cubed over 1 minus x random variable squared. My pen is running a little low. Okay, so now we need to find expected value of x given y. And what's that going to be equal to? Integral of x, f of x given y dx. Now, let's come back here to this figure. Where does x vary from? From 0 to y. So this integral goes from 0 to y. So this is going to equal to integral 0 to y, x times, what was f of x given y? Have it right here. 2x y squared dx. 1 over y squared, we don't care, we can pull it out because it's not integrating with respect. Also 2, we can pull out. 0 to y, x squared dx. Becomes x cubed over 3. So we're going to get 2 over y squared, y cubed over 3 minus 0 cubed over 3 is just 0. So this is going to become cancel, cancel. We get 2y over 3. And then expected value of x random variable given y random variable is the same thing, but we just put the y random variable here. And that completes problem 1.